Today we'll be learning about electricity. Our learning target is I will be able to describe both static and current electricity. Take a look at this list of all the different careers that use electricity in their jobs. Before we start to study electricity, we have to know some basics about charges. You might remember that protons have a positive electric charge and electrons have a negative electric charge. In most atoms, the charges of the protons and electrons cancel each other out and the atom has no net charge. But an atom can become charged by gaining or losing electrons. Static electricity is the accumulation of excess electrical charges on an object. Here you can see that we have an atom in which the charges cancel out and one in which they have not. Let's just remember that electricity is all about the way electrons move. Before we move on, let's do a quick check for understanding. Take a second to read these questions and try to answer them before we show the answers. The first question is, what is electricity all about? If you said electrons, you are correct. The next question is, what is static electricity? If you said an accumulation of charges, that's correct. And the last one is, what does the word accumulation mean? That's when a whole bunch of electrons build up in one spot. A great example of static electricity is the accumulation of charges on a balloon that cause it to stick to the wall. Another example is when electrons flow from your hand into a doorknob, causing you to feel a slight zap or tingle because of the movement of electrons. So let's take a better look at electricity. Electrically charged objects obey the following rules. First of all, the law of conservation of charge. This says that charge may be transferred from object to object, but it cannot be created or destroyed. This is the same that we studied for momentum, energy, and other things that we'll study later on in the year. You might remember from 8th grade science that opposite charges attract and like charges repel. From our study of heat, you might remember that electrons move more easily through conductors, like metals, and not as easily through insulators such as plastic, wood, rubber, and glass. In this picture, you can see that two like charges, two positives, are repelling each other. Same with the two negatives, but on the bottom, a positive and a negative attract each other. So conductors are good at conducting electricity or letting it flow. That's why when we have sockets, they're made out of metal so that the electricity can flow from the socket into whatever appliance you're using. Insulators, on the other hand, don't allow electricity to flow. That's why a lot of our tools are covered in plastics or rubber in order to protect our hands from the flow of electricity. Here's a quick picture to show you what it looks like inside a conductor, insulator, and semiconductor. So quick check for understanding. Why do conductors let electrons flow better than insulators? If you said it's because their electrons aren't stuck in place, you'd be correct. Another quick check for understanding. How does static electricity work? That's right, an object becomes charged by charges building up on one side. Those charges attract or repel other charges and sometimes try to leave the object. Here's one of my favorite topics, static discharge. This is when there is a transfer of charge through the air between two objects because of a buildup of static electricity. The most common example of this is lightning. Let's take a look. As you can see, there's a buildup of charges inside this cloud, a reason for which scientists are still unsure, but those charges tried to escape through the air, causing static discharge. We already talked about static electricity. Now let's take a look at electric current, one with which you're probably more familiar. Electric current is the flow of charges through a wire or conductor. Current is usually the flow of electrons. Think electrons, electricity. and this electric current is measured in amps, symbolized by an A. Charges flow from high voltage to low voltage, and a voltage difference is the push that causes charges to move. This voltage difference is measured in. Let's take a look at a standard electric hookup. Here you can see there's a battery connected to a conductor which is connected to a lamp, or a resistor. Keep in mind that this circuit must be a complete circle for it to function. Here's the same thing but in a schematic diagram, one which is easier to draw. One of my favorite examples of an electric current happens actually inside our bodies. Everything that you do to move, speak, or think is done through a nerve impulse, which is simply the movement of current along the spinal cord. To talk about electricity, we must also speak about resistance. Resistance is the tendency for a material to oppose the flow of electrons, changing electrical energy into thermal energy and light. All materials have some sort of electrical resistance, and this resistance is measured in ohms, which is symbolized by the Greek letter omega. Making wires thinner, longer, or hotter increases the resistance. Take a look at the flow of water in these two different bottles. As you can see, the thinner bottle has more resistance to the flow of the water. Or, if you add more resistors, such as more light bulbs, you can also increase the resistance, as you can see in this picture here. One last check for understanding. What is current and what is it measured in? Great job! Current is the flow of electrons measured in amps. What is voltage and what is that measured in? Good! The voltage is the power or the push that moves the electron and is measured in volts. Last but not least, what's the resistance? Excellent! The resistance is something that slows down the flow of electrons and is measured in ohms. Our learning target today was to be able to describe both static and current electricity. Let's see if we achieve that. Static electricity is the buildup or accumulation of charges, whereas current electricity is the flow of electrons. Of course, we know much more about these two topics, but very simply put, static is the buildup of electrons and current is the flow of electrons. If you're interested in a career in healthcare or just want to learn more about electricity, take some time to read this article about how defibrillators use electricity to restart a patient's heart. Of course, there's always more information in your IPC textbook.